Question 22 from paper 1 of the 2022 Higher Physics exam from the SQA. A circuit is shown set up as in the diagram. The battery has negligible internal resistance, the capacitor is initially uncharged, and the switch is now closed. When the reading on the voltmeter is 7 volts, the charge stored on the capacitor is, and you're given the possible responses shown A, B, C, D and E. Well, at this particular time of the charging, the voltmeter is going to read 7 volts. We put down 7 volts there. But we know that the voltage between the capacitor, the potential difference across the capacitor, and the resistor, if you add them up, will give you the voltage of the supply. So there must be 5 volts stored across the capacitor at that particular time. 5 volts, potential difference across it. And we've got a 220 microfarad capacitor. And we're asked to find the charge stored on it. So we know the definition of a capacitor. Capacitance C equals Q all upon V. And therefore we do a wee bit rearranging. We get the charge stored on the plates of the capacitor is the value of the capacitance times the potential difference across it. So that's going to be Q is going to be, in this case, C, the capacitance is 220 microfarads. That's 220 times 10 to minus 6 multiplied by the potential difference across it, and that's going to be 5 volts from our diagram there. So that gives a value of Q to be 1.1 times 10 to the minus 3, and it's going to be coulombs of charge. So our answer to that one will be, it looks like C. Question 23 from paper 1 of the 2022 Higher Physics exam from the SQA. A circuit is set up as shown, and the capacitor is initially uncharged, and switch S is closed. Now, which graphs show how the potential difference VR across resistor R, the potential difference VC across capacitor C, and the current in the circuit vary with time t as the capacitor charges? Now, it's a very difficult question because you've got so many graphs to focus in on. So the best strategy is to look at one particular graph at a time and highlight just one column. So the column we're going to highlight right now is the current flowing the circuit when the capacitor is charging. That's us highlighting that third column of graphs there. So when you initially charge the capacitor, there's no charge on the plates of it. The electrons flood onto one part of the capacitor plate, and the other capacitor plate, the electrons flee away from it, and you get a big massive current to begin with. But as charge builds up on the capacitor plates, it becomes more difficult for charge to get onto the capacitor plates because they've been repelled away. So what we're looking for in the current of a charging circuit is initially a high current flowing, which is going to fade away to zero until finally no current flows, and that's the capacitor fully charged. So we highlight that column. We can see it could be this one, starts at a high current and fades away. It's not that one. It's not that one, it's not that one, and it could be that one. So we've got two choices from our initial look at this question, looking at the current flowing while it's charging. Now, the next thing we look at is what happens to the potential difference across the resistor, because we know if there's a big current flow in a circuit, there'll be a big potential difference across R. So really, the graph of voltage across the potential difference across the resistor is going to be the exact same shape as the current in a circuit while it's charging. So it's not going to be that one. It's not going to be this one. Well, it is going to be this one because you can see it's the same shape. The voltage starts high and falls away. So it could be that one. It could be that one, and it could be that one. So we're beginning to sort of like tease out which graph it will be. And all we've got left is that middle column, which I've highlighted there. And that's the potential difference across the capacitor. Now, as more and more charge arrive in the capacitor plates, the bigger the potential difference across the capacitor, which means initially there's no charge on the plates, there's no potential difference across the capacitor. So we're looking for a graph where we have no potential difference at the start across the capacitor, and it rises as charges arrive in the capacitor and levels off when it's fully charged. So it's not that one. It's not. Well, it could be that one. Yep, that's rising up, zero, rising up and leveling off. Not that one, not that one, and yeah, that one there. And look, we've got 3 graphs ticked, and that must be the answer. Answer E.